Good day, students. Welcome to part 2 of the ELM placement test review. I'm going to be going over questions 11 to 20. Just like in the first part of this clip, this presentation, I told you that this document that I'm going over is accessible on the internet, www.csumathgotserved.org/exam_prep. And then you go to the free questions, and then you're going to have access to this document, okay? So let's go ahead and start with number 11. Number 11 says that the number of atoms of platinum in the universe is estimated to be 1.4 times the number of atoms of silicon in the universe. The number of atoms of silver in the universe is estimated to be 0.33 times the number of atoms of silicon in the universe. Based on these estimates, the number of atoms of platinum in the universe is approximately how many times the number of atoms of silver in the universe. So let's say I want to declare my variables. So let's PT be number of platinum, number of atoms of platinum, okay, and then SI number of atoms of silicon, and AG number of atoms of silver. Okay? Alright, remember whenever you see the word is basically means equal. Okay, don't forget. If anytime you see is and you want to generate an equation, is basically equal. Okay? So when you see number of atoms of platinum is 1.4 times the number of atoms of silicon. So we start with platinum, PT is equals 1.4 times is basically 1.4 multiplied by silicon, 1.4 SI. Okay? So that's my first equation right there. All right. Now how about the second equation? Second equation, number of atoms of silver is, so we're going to write AG is equal to 0.33 times is basically multiply number of atoms of silicon, Si. All right. So the question is based on these estimates, the number of atoms in the universe, the number of atoms of platinum in the universe is approximately how many times the number of atoms of silver in the universe. So basically, they want us to write PT as a multiple of AG. So they basically want us to do PT equals some random number multiplied by AG. Okay, so what is this number right here? In order for us to do this, we need to make a substitution. Okay, let's say this is equation 1, the first equation, and this is the second equation. If I can express the second equation in terms of SI, I can substitute that SI value here, and then it's going to be AG. All right, so I need to get SI by itself here and replace whatever multiple of AG I have here into that, and then that will basically give me what I want. All right, so let's start from 2. From the second equation, I want to get SI by itself so I can make a clean substitution. We have AG equals 0.33 SI times silicon. All right, how do I get SI by itself? You divide, right? Divide both sides by 0.33. 0.33. These two cancel out. So you have SI equals silver over 0.33. Okay. Now I have SI by itself. What am I going to do in equation 1? I need only PT and AG in equation 1. So what am I going to do? I'm going to substitute this value for SI in equation 1. Okay. So I'm going to substitute in 1. All right. I'm going to substitute in 1 this for SI. So if I make a substitution, what I'm trying to do here, I'm going to take this and I'm going to replace it, put it in for SI over there. Okay? Alright, so if I do that, I'm going to have PT, put it up a little bit, PT equals 1.4, instead of SI, I'm going to put AG, which is silver, over 0.33. Okay? And then that's, if I rewrite it, I'm going to have PT equals 1.4 over 0.33 times silver. So 1.4 over 0.33 will give me my answer, okay? If you look at the options we have right here, they are all reduced, they are all decimals, so I need to divide this out, okay? So what is 1.4 divided by 0.33? I'm going to move the decimal point. I want to clear the decimal on the bottom, so I have to back it up once, twice, and then top the same number of times. 1, 2 is like I'm multiplying by 100, so put a 0 here. So this becomes 140 over 33. How do we do this? Let's do long division. All right, long division, 33 divided by 140. 33 doesn't go into 14, so we need to go to the whole number. 33 times 3 is 99, too small. 33 times 4 is 132, so I think that should work. 33 times 5 is, I think, 165, so that's too big. So 33 times 4, 132, subtract 8, it doesn't go, it's too small, so put a decimal point here. That gives us the right to add a 0, but please, let's see. We already know the answer is E, right? Because that's the only one that's 4 point something, so the answer to this is E. Okay, because you can go on if you want, put a 2 here, 66, and minus it and keep going on and on. Alright, so there you have it, the answer is E. Alright, let's move on to question 12. And question 12 says, certain medicine is prescribed in an amount proportional to a patient's body weight. If a patient weighing 70 kilograms requires 210 milligrams of this medicine, then the amount of medicine required for a patient weighing 80 kilograms is, since there's a proportionality here, we can express them as two fractions, okay? And then we solve for the unknown, all right? So let's put 12. So it says, and the amount of medicine required per patient. So let's declare what I need. Let X be required amount of medicine. Okay, that's what we're looking for, amount of medicine. Now, if you declare variables, it's easier for you to generate an equation and solve algebraically. Okay, so I'm going to set up a ratio. On the numerator, I'm going to have body weight. Okay, body weight goes on top. Body weight goes on top, and over amount of medicine goes on bottom. Okay, amount of medicine. Okay, that's the denominator. All right, let's set up the ratio. So for the first one, we know that someone weighing 70 kilograms is going to have 210 milligrams. Okay. All right, but how about 80? Or if you weigh 80 kilograms, how many kilograms are you going to have? How many kilograms of medicine is required? We do not know. So that's X. That's what we're looking for. Call that X. Okay. Whenever I have a fraction like this, you can solve by cross multiplying. So when you cross multiply, denominator goes to top, and denominator goes to top like that. That's what cross multiply is. And you have 70x equals 16,800. Alright, to get x by itself, divide both sides by what? 70, right? Divide this by 70, divide that by 70. And then you're going to have x equals, when you divide 16,800 by 70, you end up with 250. 250 milligrams is the amount of medicine that an 80 kilogram person will need. So the answer is C. Okay? Alright, let's move on to question 13. Question 13 says, Joel mixed 3 tablespoons of plant fertilizer with 2 liters of water in order to obtain the same ratio of fertilizer to water. How many tablespoons of fertilizer must he mix with 5 liters of water? So, let's declare variables here again. So, let T equals number of tablespoons of fertilizer needed. Okay. All right. Now let's set up an equation. I'm going to use the same approach as I did before. Let's have number of tablespoons as the numerator. Number of tablespoons as the numerator, and amount of water as a denominator. Amount of water as a denominator. Okay, so let's see. So for 3 tablespoons, we have 2 liters of water. How about for 5 liters of water? How many? What's that? So the amount of water goes on the bottom. So 5 liters of water, we put a 5 down here. And then how many tablespoons do we need? X. Remember, tablespoons goes on the top and liters go on the bottom. So you have 2 liters down here and then 5 liters down here. Okay? So how do you solve this for X? This is an easy equation. Just get rid of this 5. Since this is divide by 5, the opposite is multiply. So multiply by 5. So you're going to have 15 over 2 equals X. 15 divided by 2 can be written in mixed number form as 7, because 2 goes into 15, 7 times remainder 1, 1 and a half. Okay, and the answer is D. Okay, so just make sure you name your numerator and denominator. You could do this in the reverse way too, you still get the same answer. But just keep the same unit of measurement in the same area. So either tablespoon goes on top or bottom, and then amount of water should be on top or bottom. Keep them consistent. Okay, so there goes the answer. Alright, let's move on to question number 14. It says, how many dollars will X pen cost if 5 such pens cost Y dollars? Alright, this one's a little bit tricky because you have all those variables taken out. So if 5 pens cost Y dollars, then so in this problem, I'm going to attempt to find the unit price and then multiply by X. Okay, so what's the unit price? If 5 pence cost $1, how much does 1 pen cost? 5 pence costs $1. I mean, 5 pence cost Y dollars, then 1 pen. In order to get 1 pen, I need to divide this by 5, right? Divide this by 5, divide that by 5. 1 pen is going to cost Y over $5. Okay. Alright, so this is a unit price. Now what if I want to get X pens? To get X pens, if 1 pen costs X dollars, to get X pens, I just simply multiply this equation by X. Okay? So if 1 equals Y over 5, then to get X, the cost of X, I just simply multiply both sides by X. Multiply this by X, and multiply that by X. So X pens is going to cost XY over 5, because every one costs Y over 5. So if you wanted to get 3 pens, for example, 3 pens is going to be the unit price times your quantity, right? So 3 times Y over 5, 3Y over 5. If you want to have 4 pens, it's going to be the unit price, which is Y over 5, times the quantity, 4 times Y over 5, okay? So if you get the unit price down, whatever amount you want, just basically multiply that amount by the unit price, and that basically gives you your answer. So X pens is going to cost XY over 5, which is basically 8. Okay? So that goes your answer. Alright, let's take a look at number 15. Number 15, we have, it says, according to the table below, which of the following best approximates the total enrollment at Central College? So, there's some approximations going on here. We have 1816, 1473, 1431, and 1298. If you look at the alternatives, everything is being rounded up to the hundredths place. Okay, so we're rounding up to the hundredths place. This is the hundredths place. Okay, so to do this, remember the rules for rounding, right? If it's less than 5, you round down. If it's greater than or equal to 5, you round up. Okay, so what we're going to do is examine the hundredths place of all the numbers, and then see, examine the number before the hundredths place, and then see if we're going to round up or round down. Okay, we're going to add 1 or or do nothing. Okay, so this one is less than 5, so we're going to round down to 1800. This one's going to be rounded, this one's going to be approximately 1800. 7 is bigger than 5, so this one is going to round up, so it's going to be approximately 1500. So you round the hundreds place up because the number before it is bigger than 5. 3 is less than 5, so we're going to round down. So 1431 is approximately 1400. 9 is bigger than 5, so you're going to round this up. This is going to be approximately 1300. Okay, so the best approximation is going to be 1800 plus 1500 plus 1400 plus 1300. Let's see which one the matches. 18, 14, 18, 15, 14, 13. Answer is C. Okay, this is for number 15. Alright, let's move on to number 16. This one says, in the music class of 30 students, there are 6 more females than there are males. How many females are in the class? So, let's see. Let's describe the number. Let's just say, since females were expressed in terms of males, 6 more females than males. Let's just say let x equals number of males. Okay. So basically, the total number, which is 30, is going to be the number of males, it's just x, plus the number of females. Females are 6 more, right? It's just x plus 6. Just add 6 to the number of males equals 30. And we solve this equation, that will give us the number of males. Okay, remember this right here. This is males, number of males, and this right here is number of females. Okay? Alright, now let's solve it. So to solve it, this becomes 2x plus 6 equals 30. To get x by itself, you subtract 6. You have 2x equals 30 minus 6 is 24. Divide both sides by 2. X equals 12, alright? So this is the number of what? Is it 12? No. This x is the number of males, so you have to be careful here, okay? We asked for the number of females. Females is males plus 6, so we're going to have 12. So females is basically 12 plus 6, number of females. 12 plus 6, which is 18. So our final answer is C. Alright, so you have to be careful. Sometimes you won't finish the problem, but there's a distractor there to deceive you. So you have to make sure that you're finding exactly what the question is asking for, okay? Alright, let's take a look at number 17. It says, over the last 30 years, the speed of microprocessors have become approximately 4 times faster every 3 years. Based on this information, microprocessors made today are approximately how many times as fast as microprocessors made 9 years ago? So, 9 years ago, today 9 years ago, that's a little bit abstract, so let's make it concrete, okay? So let's say this year is 2009, okay? Because it's easy to do 9 years ago. So 9 years ago is going to be 2000, alright? So starting from 2000, we're going to be going increments of 3 years. So 2000 plus 3 years gives us 2003. How fast did the processor get? It went times 4. And then 2003 went another plus 3 to 2006. Went another times 4 times faster. And then from 2006 to this year, 2009, another 3, 4 times faster. Okay? So assuming that this year is 2009, from 2000 to 2009, it went 4 times, 4 times, 4 times. So it's 4 times 4 times 4. Okay? And the exponents are 1, 1, 1. So when you multiply, you add the exponents. This is 4 to the third. Okay? Because basically 4 to the 1 plus 1 plus 1, which is 4 to the third. So that's your answer. The answer for number 17 is D. Okay? Alright, let's move on to number 18. Number 18, we have this abstract number line right here. It says, which of the following must be true about numbers x and y graphed on the number line above? So let me try to replicate a number line that's has similar characteristics as this one illustrated here. You're given 0, 1, negative 1, and then the next part right here is y, and then a little bit further off is x. Okay, so when you're working in situations like this, instead of working in abstraction, you can assign good guesses to x and y and then use that instead of using abstract values. Okay, so what can we guess that y is? I can guess that y is 2. Is that a fair guess? It looks like 1, 2, right? What can I guess that x is? I can guess that it's, let's say, -5. Okay, because it's much further from 0 than y is. Okay, so this is like -5 or -4 will be a good guess. Okay, so now let's test these three inequalities and see which one holds. So the first one is x plus y is greater than 0. Is that true with these values right here? Is -5 plus 2 greater than 0? What's -5 minus 2 plus 2? Signs are different, so you subtract and keep the sign of the bigger one. So -3, is it bigger than 0? No. So 1 is false. I. Okay, is y minus x greater than 0? Is 2 minus, remember x is -5, so be careful. 2 minus -5, is it bigger than 0? If you have minus and a minus being multiplied or divided, it would become a plus, right? So you have 2 plus 5. Is 2 plus 5 bigger than 0? Is 7 bigger than 0? Absolutely is. Yes. So statement 2 is true. How about statement 3? xy. Is xy bigger or greater than 0? Is -5 times 2 bigger than 0? -5 times 2 is -10. Is -10 bigger than 0? Is it? Absolutely not. It's smaller. Okay? So the only true statement is II. Okay? So the answer is going to be B. So the answer for number 18 is B. Okay, so anytime you have a situation like this, always pick numbers to help you have a good idea as to what you're working with. Alright, let's take a look at number 19. Number 19, it says which point on the number line above could be represented by the square root of 10? So, is it between these two, those two right there? So, I'm going to start, I have 2. I'm going to line it up like this. I have 2, 2, 3, 4, 5. Let's stop there and see. Okay, so 2 square is 4. 3 square is 9. 3 square is 9. 4 square is 16. Uh-oh. Do you see where 10 is? 10 lies between 3 square and 4 square. If 10 lies between 3 square and 4 square, that means the square root of 10 lies between 3 and 4. Okay, so it's supposed to be somewhere between 3 and 4 because the square root of this takes it to that, and the square root of that takes it to that. So if the squares of these two numbers is before and after 10, that means the square root is going to be before and after the square root of 10. So the square root of 10 is between 3 and 4 because the squares 9 and 16 are before and after 10. So the answer to this is B, because B is between 3 and 4. So number 19, your answer is B. Okay, so that's basically how you have it. All right, let's move on to number 20. It says, number 20 says the square root of 24 is a number between what? This is similar to the one we just did. Square root of 24. So we have 0, 1, 2, 3, 4. We're gonna square these numbers. If we hit a number that's before and after 24, then the number is 24 is going to be between them. Okay, so when I square this, I get 0. Square this, I get 1. 24 is not between these two. When I square this, I get 4. 24 is not between this. When I square this, I get 9. 24 is not here. When I square this, I get 16. 24 is not between them. 5 square, I get 25. Voila! 24 is between the square of 3, the square of 4, and 5. So if 24 is between the square of 4 and 5, guess what? The square root of 24 is going to be between 4 and 5. It's going to be right between these two numbers right here. Okay? So the square root of 24 is between 4 and 5 because the square of 4 and 5, 24, is between both of them. Alright, so your answer for this one is E. Okay? Alright. Thanks for paying attention to part 2 of this presentation. This is the end of the number sense section. The next section is going to be data analysis, and I should be uploading it shortly.